À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain. Allumage des EAP, décollage. La propulsion est nominale, les paramètres bord sont nominaux. La trajectoire est normale, les paramètres bord sont normaux.
And there she goes, lighting up the night sky over the equator. Here at the Guyana Space Center, we've broken the sound barrier. We're traveling supersonic, faster than the speed of sound, which is just over 1,200 kilometers an hour at sea level. And we've got clear skies tonight, so we might just get lucky and see the boosters with the naked eye falling away. Those boosters are doing all the work right now, providing 90% of our thrust and burning at 3,000 degrees Celsius.
Séparation des étages d'accélération à poudre.
And you can see them. You just saw them there falling away. And these are images from a previous launch. We don't need them anymore. They've burnt all their propellant. And we're shedding weight. We've already lost about 3/4 of our weight in just over 2 minutes. And you can see there we are now burning the main stage, that tank of cryogenic propellant, the grey tank. He's telling us that everything is going according to plan. If you look at the top of the launcher, you can see the fairing there. That's protecting the satellite. There's the acoustic vibrations at liftoff. Well, I'm sure you can imagine that it's extremely loud. And friction, of course, because until now we've been flying through the dense part of the atmosphere. But if you look at the bottom left-hand corner, you can see that our altitude is 120 kilometers above the Earth. So we're now on the outer edge of the atmosphere. And we no longer have friction because we are effectively
Largage de la coiffe.
in space now, and we're able to jettison and look at it go. Can you see how it moves there? That's called the breathing mode. All part of the plan. And those parts flex as they fall. Incredible to think that it takes less than 4 minutes to climb out of Earth's atmosphere. That's all that separates us from space. Makes life possible here on Earth. So we can see Eutelsat 65 West A for the first time now.
Vu de la manœuvre en roulis, la trajectoire est normale, les paramètres bord sont normaux.
Everything's going normally, he says. And if you look on the right-hand side of the screen, you can still see the image there of the satellite, the solar panels, and at the front, the reflectors. We're just launching one satellite today, which is unusual for Ariane 5. Normally she takes at least 2, if not more, spacecraft on board. And interestingly, this is the 7th single Ariane 5 launch of a geostationary satellite, and the previous one was on the 27th of January this year. That was carrying Eutelsat 29E. So both of the first 2 launches this year have been single launches. So here we can see Galileo is the tracking station at the Guiana Space Center, and the next one along is Natal on the northeast coast of Brazil. There's the Vulcan engine on the main stage, the blue flame on the left-hand side. It's extremely powerful. It burns 320 kilograms of propellant per second. That's 500 times more than a jet engine. Everything's normal, he says. So let's take a look now at the screen. At the bottom is our altitude, bottom left-hand side. We're 199 kilometers above the Earth. In the middle is the distance, and that's the distance along the ground from the pad, if you were to draw a straight line along the Earth. And the speed on the bottom right-hand side, we're coming up to 4 kilometers per second. Ladies and gentlemen, let me remind you that it's per second, not per hour. That's phenomenally fast. And on the top right-hand side, you can see the trajectory. The curve is the plotted path of the vehicle, and the white dot is the actual position of the launcher. Our next tracking station to pick up the signal is Natal in Brazil. And we've just had confirmation there from the range operations manager that we have picked up the signal there in Natal. We're heading out across the Atlantic. The flight path takes us along the equator across Africa. And we're going to start separating our satellite over the east coast of Africa. And the ground stations along the flight pick up the signal as Ariane flies over. We call that telemetry because Ariane then sends data to those ground stations. And this is going to tell us how the flight is progressing in real time. Then later, of course, we can see how the vehicle performed. And all that is analysed. It's called the Level 0 Flight Evaluation, and that takes place a few weeks after the launch. The Space Centre is, of course, on the equator, and there are a few advantages of launching from the equator. It is the fast to geostationary orbit, and it also helps us with the natural rotation of the Earth. This was 8 minutes and 34 seconds ago. We took off from the pad at the Guiana Space Center on the northeast coast of South America, the Amazonian coast, on the edge of the rainforest.
Extinction de l'étage principal cryotechnique sur commande de guidage, séparation de l'EPC.
So he's just told us that we have now switched off the engine and lost the main stage and switched on the engine of the upper stage.
Moteur de l'ESC.
And this is the beginning of the next phase in the journey. The upper stage has taken the wheel. It's a bit like a driver. It's going to transport the satellite to its correct orbit so that we can separate it, because the satellite will then have to head out on its own journey. Teams here concentrating hard in the Mission Control Center Eutelsat Communications is one of the world's leading satellite operators. This satellite's going to be providing some very important services across the Americas, in particular South America and Brazil. And Eutelsat's fleet provides capacity for lots of different clients, including broadcasters and pay TV operators, video, data, internet, enterprises, government agencies.